Hey guys, welcome to our first video of our Zomu EDU Intro to Computer Science series. Basically, in this series, we're going to learn how to understand the basic fundamentals of coding in Java. So today what we're going to go over is how a basic Java program does what it does. And why is this important? Well, as we go on in this course and we understand how to write more advanced code, it's great. We can actually do certain assignments like maybe calculating change or adding or subtracting fractions. But we don't really know what's going on in the background. And we can't really appreciate what's going on in the background. So conceptually, it's going to be very helpful to understand what's really going on when we write a line of code in Java. And that's what this video entails. So basically on the left side of the screen, I have a flowchart, which basically goes through all the processes that happens when we write a line of code and we execute it or we run the code. So we have 1, 2, 3, 4, 5, and 6 major key steps that occur when we write Java code and we run it. So the first one is Java and data. So what does that mean? Well, when we write code, we have to write it in a certain language. And there are many languages out there like Python, C++, and Java is another language along with those other ones. So we are writing and we're learning to write in Java. So what I wrote here in what I highlighted right here is Java. Int x equals y, int y equals 7, int z equals x plus y, and then displaying that. Of course, we didn't really go over that yet, and we will, but this is writing in Java. The language that I've written in is Java. And whenever I write a line of code, it takes up space in the memory of the computer and of this IDE. It takes up space. And we also call that data. We say that it takes up data. So with every line of code, it's taking up some space in the IDE. So when I write int x equals 5, it takes up some more space. Int y equals 7, some more space. Int z equals x plus y takes up even more space. So that's why a lot of coders, when they start to write code that is 10 to 15 pages long, they want to try to simplify their code as much as possible so that they can make it efficient. And basically making your Java code efficient means to still get the assignment done. It's to get your end goal. You want to meet your end goal and execute what you want to do correctly, but you want to do it in as few possible lines as you possibly can. So you want to try to minimize the line of code or the lines of code that you write in, but still get the job done. So hopefully that makes a little bit of sense. So we start off with Java, and that Java takes up data. And now that we have this Java language, we're going to put it in a Java compiler. And what this Java compiler does is it takes the Java language, it takes whatever I wrote here in the highlighted area, it takes whatever I wrote here and it translates it or it converts it to another language. And this language is called bytecode. So I guess to give a metaphor, let's say you decided to visit the Great Wall of China and you're not Chinese and you don't understand how to speak Chinese. Well, let's say you really wanted to get a message across to a person that only speaks Chinese. Well, what would you do? You would write what you wanted to say in Chinese in English. So let's say you wanted to say, how many miles long is the Great Wall of China? Well, you would write that in English and put it in Google Translate, which is a compiler. And then Google Translate would output whatever you wanted to say in Chinese. Just like that, the Java compiler takes in one language, which is Java, and it converts it to another language, which is called bytecode. Just like how you converted English to Chinese when you were a tourist visiting the Great Wall. So this Java compiler, why it's so important, is because the computer doesn't understand the Java language. It needs to be converted into a language that it understands, just like how the Chinese person you're talking to doesn't understand English. So in order to communicate with both parties, you need to use a common language, and that is bytecode. So Java compiler, it converts Java into bytecode, which the computer can actually understand. And this bytecode is just a bundle of letters and different aspects that the computer can understand, but it still is not readable. It's still not something that you can actually execute. And why is that? Well, to give you guys another metaphor, read this sentence. He ate food, he wanted to sleep, he couldn't since his bed broke. Well, it was very difficult to read that, right? And one of the reasons why is because there are no spaces, and another reason is because there are no punctuations. Even though we could kind of make out what it had to say and we could read some words, it was very difficult at the end of the day. So, in order to make this actually readable, what we have to do is we have to add spaces, maybe some punctuation marks after he ate food, he wanted to sleep, he couldn't since his bed broke. So, a very sad story, but it helps in the metaphor. So now we can actually read it easily. He ate food, he wanted to sleep, period. He couldn't since his bed broke. And I know this sounds like a grammar class, but bear with me for the metaphor. So now we can read it. Opposed to what we had before, it's a lot more easier to read now. So when we converted Java to bytecode, it was still very hard for the computer to read that bytecode, even though it could make out a couple words, because it's a language that the computer knows. So in order to make it easier to read, we put it in something called the bytecode interpreter. So when we put it in the bytecode interpreter, metaphorically, it kind of adds the spaces and the punctuation marks so that the computer can actually understand what the bytecode is saying. Now, in real life, is it really adding periods, punctuation marks, and spaces? No, but that's just for the metaphor's sake. So now that it actually is converted into something the computer can understand and it can translate line by line and execute, we put it into something called the machine language, which basically means that it takes segment for segment. So each command that the Java code has, or the bytecode has rather, each command that the bytecode has, it executes. So he ate food. It would execute that. He wanted to sleep. It would execute that. He couldn't since his bed broke. It would execute that. So now it's reading line for line what's actually happening in that code. And then finally, it outputs whatever the code wants to execute. So I guess the best way to show that is to show an actual example. So I have int x equals 5, int y equals 7, and int z equals x plus y, and then I have system.out.println z. And you guys shouldn't really understand what that means. If you guys do, then you guys are very ahead, and good for you. But since we didn't really go over that, I don't expect you guys to understand what this means. But this is just, as I mentioned before, code in Java. And what I'm basically doing here is I'm adding 5 plus 7, and I'm displaying my answer. And you'll understand why later on when we go into what each of these lines mean. So when I run the program by pressing this play button, I guess you can look at it as, it displays 12, which is correct. 5 plus 7 is 12. So how did I go from this arbitrary language called Java into displaying something that actually is correct and makes sense? Well, I went through these 6 steps. I wrote in Java that took up data. I put that Java language in a compiler and converted it into bytecode. And then I put that bytecode into a bytecode interpreter that actually made the bytecode easier to read and actually sensible. And then I converted that bytecode and read it line for line into the machine language. And then I finally executed my answer. So in this case, this highlighted area would be my Java and data. Java compiler, bytecode program, and bytecode interpreter would be everything that's happening in the background, and also machine language. And then finally, my output is something that we all see to be 12. So hopefully you guys understand what's going on in the background when we're writing Java code. And hopefully you guys understand what's really going on and how much work it takes to actually write Java code and to actually display it. Hopefully you guys understood this lesson. If you guys have any questions, comments, or concerns, please leave them in the comments section below, and I hope you tune in for more. Thank you.